Assalamualaikum and hello everyone. So we continue another subchapter for chapter 5, which is a graphical method for constructing shear and moment diagrams. Page 97, which is example 5.5, you have to do by your own until you get the shear force and bending moment diagram. After that, you have to identify what is the maximum shear and also what is the maximum moment. For today, we will learn about the graphical method. Okay, as I mentioned, in the learning outcome of this chapter, you have two methods to analyze the beam, which is by using equation that we have learned in previous subchapter, but now it's a graphical method. Graphical method is the easiest way to construct the shear force and bending moment diagram. In order for you to answer question for shear force and bending moment diagram, you have to know both method. Okay, you have to read the question carefully. Which method the question asks? If the question asks you to analyze the beam by using equation, then you have to use equation or expression. If the question asks you to analyze the beam by using graphical method, then you have to use a graphical method. Take a look at the graphical method. The following two equations provide a convenient means for quickly obtaining the shear and moment diagram of the beam. The slope of the shear diagram at each point, when you differentiate the shear, then you will get the load at the beam. When you differentiate the moment equation, then you will get the V value. In graphical method, without cutting the segment, you can easily get the shear force and bending moment diagram. First, you need the Freebody diagram with the support reactions value, and then from Freebody diagram, easily you can draw the shear force diagram, and also from shear force diagram, easily you can draw the bending moment diagram without any calculation, only for support reaction. You just calculate for support reaction, and then straight away you can get the shear force diagram and bending moment diagram. So different with equation or expression method. For equation and expression method, you have to cut the beams in order for you to expose the internal forces of each segment, and then from equilibrium equation you can express the equations. From that equation you have to draw shear force and bending moment diagram. But different in graphical method, here it's very easy. You just need Freebody diagram, and then from Freebody diagram you draw shear force diagram, and then from shear force diagram you draw bending moment diagram. It's very easy. You also can integrate the areas between any 2 points to get change in shear and also a moment. So in order for you to get the shear, you have to integrate the W. In order for you to get the moment, and then you have to integrate the shear. For graphical method, you have to know the pattern of shear and moment diagram for each loading cases. Okay, for example, this is a point load. For point load, for shear diagram, you have a straight line. For moment diagram, you have inclined line or diagonal line. Different for UDL, you will have inclined line for shear diagram, but for moment, you will have a curve, because in moment, remember back the equation or the expression. For UDL, you will have a quadratic equation. So that's why for moment diagram, the line is curved. For linear distributed load, for shear diagram you will have a curve, and also for moment diagram you also will have a curve, because both will give you a quadratic equations. For you to draw the shear force and bending moment diagram, you need to know the pattern of shear force and moment diagram for each loading cases. So take a look at example 6.4. Take a look at example 6.4 in page 99. So this one we already try by using expression, but now we want to try by using graphical method. So first you have to calculate the support reaction. AY you already calculated, which is 18 kilonewton, and FY you already calculated, which is 18 kilonewton. Okay, you have to calculate this one, but since we already calculated this one, so I just take the value. First you have to draw Freebody diagram. Freebody diagram with all the support reactions value. Then you have point load. Without any cutting of the segment, straight away you can draw the shear force and bending moment diagram. First you draw the dotted line. Dotted line at each segment. Use your ruler. And then draw analysis. This is shear force diagram. Put the labels. Same goes to bending moment diagram. First we draw the shear force diagram. If you look at point A here, you have 18 kilonewton upwards. So from 0 you move upward about 18. Okay, and then is there any load applied between AB here at this point? Is there any load? No. Okay, so no. So you go up here and then you go straight. So the value still same, which is 18. And then at point B, here at point B, C, D, E and F. Okay, you put the distance also. So 18, this is downward. So 18 minus 9 is equal to 9. Okay, so you go down a bit. So this is 9. So is there any load between BC? Nothing. So you go straight. Same, 9. And then 9 here, and then 9 downwards. 9 minus 9 is equal to 0. And then nothing between CD, you go straight. And then at point D you have 9 downward. So downward minus 9. Between DE you have nothing. Okay, you have nothing, so go straight. Another negative 9. And then at point E you have 9 downward. Negative 9 minus negative 9 is equal to negative 18. And then between EF you have nothing, and then you go straight. 18. And then you have 18 at point F, which is upwards. Negative 18 plus 18 is equal to 0. So it closes the loops. Okay, very easy. You just look at the Freebody diagram. From Freebody diagram you can draw the shear force diagram. To draw the bending moment diagram, you need the area under shear force diagram. How to calculate the area under shear force diagram? Distance is 0, 1.2, 2.4, 3.6, 4.8 and also 6. So you can calculate the area. What is the shape of this one, class? This is a rectangle. How to calculate the area of rectangle? It's easy. 18 times 1.2, which is the base here, is equal to 21.6. And then after that, you calculate area of this rectangle. It is 9b times d. 9 times 1.2 is equal to 10.8. Then this one, what's the area? 0 times 1.2 is equal to 0, no area. And then the area of this one, negative 9 times 1.2 is equal to negative 10.8. And the last segment, negative 18 times 1.2 is equal to negative 21.6. So you have to take the negative value. Once you have all the areas value, then you are ready to draw the bending moment. At the first point, which is point A, do you have any applied moment? No, right? So it should start from 0. If you have applied moment at point A here, you have to put the moment. But since there is no applied moment at A, then we put it as a 0. Then between A, B, you have this area which is 21.6 positive. So you go here, 21 is a cumulative. 21.6 plus 10.8 is equal to 32.4. And then 32.4 plus 0 is equal to 32.4. 32.4 minus 10.8 is equal to 21.6. 21.6 minus 21.6 is equal to 0. Okay, then you close the loop. Then connect all the point. This is point load. It should be straight line but incline. Incline line. So you have the bending moment diagram. After that, identify the maximum V. Is equal to 18 kilonewton. Maximum moment is equal to 32.4 kilonewton meter. You have to try by yourself so you can understand more. So we try this one. This example in page 100. Draw the shear and moment diagram by using a graphical method. As already mentioned, here is a graphical method. A is a pin, B is a roller. By support reactions, then you will have this value. What is your AY value? AX value? And what is your BY value? Please calculate this one. First step, you need to calculate support reaction. It's a must. Or else, your shear force diagram and bending moment diagram will not equal to 0 at the end point. After you calculate the support reaction, then you have to draw Freebody diagram. we use a graphical method, so no need to cut the section. So you give me the AY value. By calculation, you will get AY is equal to downward, which is 2 kilonewton. Or else you can put it like usually, see, 2 kilonewton. And then this is point E. And then you have a UDF, Y. You have a UDF, 4 kilonewton per meter. BY, you have 10 kilonewton. It's an overhanging beam. And then put the distance. At the bottom, you draw the shear force diagram. Draw a line. Draw a dotted line at each point. And then do the shear force diagram. Label the axis. And then at the bottom, and then put the distance. Then draw the bending moment diagram. Now we're good to go. If you refer to Freebody diagram, you have 2 kilonewton downward. So from 0 until 2 kilonewton, negative 2 because it's downwards. Between AB, you don't have anything, so you go straight. Negative 2. And then at point B, you have 10 kilonewton upwards. Negative 2 plus 10 is equal to 8. And then you go up until 8. So this is 8. And then you have this UDL. So refer back to the notes, and if it is a UDL, then the line for shear force should be straight line but inclined. How to convert kilonewton per meter to kilonewton? So kilonewton per meter times meter is equal to kilonewton. Then you have to times the distance. 4 times the distance of UDL is equal to 2. 4 times 2 is equal to 8, but it is downwards. 8 minus 4 times 2 is equal to 0. So this point is 0. Then take a ruler, do the straight line for this one. Okay. Then you have the shear force diagram. How to calculate bending moment diagram? As I mentioned, you need the area under shear force diagram, and then calculate the area. This is a rectangle. Negative 2 times the distance, which is 4, is equal to negative 8. This is a triangle. 1 over 2 times 8 times the base, which is 2, is equal to 8. So you have two values, negative 8 and 8. So we start for bending moment diagram. If you look at the diagram, Freebody diagram, do you have any applied moment? No. Then it should start from 0. And then between AB you have negative 8, and then you go up, you go here, negative 8. And then negative 8 plus 8 is equal to 0. AB is a point load. For bending moment diagram, for point load, the line is a straight line but inclined. And then BC, you have UDL. UDL, the line for bending moment diagram is a curve. So you need to draw a curve. Then it closes the loops. is a straight line and this one is a curve. So you determine the maximum V and what is your maximum moment. Okay, for page 101, this question you have to try by your own. So this is the secondary beam. So you need to convert the secondary beam into a point load. So if you push here, then this one will rotate. So you have a new diagram, which is a UDL. And then at point D, you have two load, which is 45, the applied load, and also the moment because of the rotation from the secondary beam. (45) times 0.6 is equal to 27. And then you have the fixed point. This is point A, point C, point D, and point B. There is no point E. Okay, solve this one until you get the maximum moment. I just give you the maximum moment value. Maximum moment is equal to 429.3 kilonewton meter. If you get this maximum moment value correct, means that your shear force diagram and your support ratio is correct.